Hi everyone, this is the help video for the 7.03 quiz, Measures of Center. In this quiz, we're going to be going over the standard DP 1.1, so we're determining the appropriate measure of center or measure of variation, and then we're going to be able to summarize that given numerical data, either numerically or graphically. And we're also going to be discussing outliers and skewed data. So in order to best use this help video, please go ahead and open up your quiz. Direct link is in the grade book. If you are waiting for your second attempt on that quiz, then you can just use this video to help you prepare, and then you can take that quiz once your second attempt is available to you. The first thing that we're going to review today is measures of center. Measures of center is not a new concept to you. This is something that you first learned in 6th grade. When we're talking about measures of center, there's typically four that people consider to be a measure of center: mean, median, mode, and range. For sake of 7th grade, we are not going to use mode. That is specific only to 6th grade. But we do talk about mean, median, and range. So let's just go ahead and discuss those three for a second. The mean is the average value of the data. In order to calculate the mean, you're going to add up all the numbers, and then you're going to divide by the number of values in your data set. So the goal when finding the mean is to find the average of all the numbers. Next is the median. Median is best described as the middle number of a data set. So in order to best find the median, you're going to put the numbers of your data set in order from smallest to largest. And then once they're in order from smallest to largest, you're going to locate the number that falls right in the middle. So again, median, the keyword there is going to be that middle number. So you can do that visually just by crossing off from the outside until you get closer into the middle. And then finally, we have range. Range is the difference between the highest and the lowest number in a data set. So when you're looking for range, you're really looking for what is the vastness of the data set. And so in order to do that, you're again going to put in your numbers from your data set from smallest to largest, and then you're going to identify the largest, your maximum, and your lowest, the minimum, and you're going to subtract those values. So again, it's important to understand how to calculate these three different measures of center, especially as we talk about measures of center in this lesson. Now, once you're given a data set, it's important to be able to identify, especially visually, if you're given it in graph form, like you can see on the screen here, if your data is skewed. So skewed data means that there is a tail from one side or another. The other best way to describe the way that skewed data looks is something that's not balanced or not even. So if we see something that's skewed, we would see something that is shifted to one side or another, not something that has balance within the graph. So as we can see in these three graphs that are shown on the board, this one does show skew. So it is skewed over. It is not a balanced graph because it does not centralize in the middle. This second graph right here, we would consider to have no skew. This is a very balanced graph because all of our values are lying equally. Now, you don't have to have this curve in order to have lack of skew. You could have a graph that is straight all the way across or has very minimal variation. That would also indicate a lack of skew. But this is an example of lack of skew just because it is not shifted to one side or another. And finally, this third graph, this also does show skew. Again, we can see that there is a lack of balance in this graph. It is shifted over to the left side. So what does skewed data really indicate to us? So when we're looking at these graphs, what does it mean when we have data that is skewed to one side or another? Well, it indicates to us that we have an outlier in our data set. So an outlier by definition is an extreme value in a data set. We can see on the screen here the data set as shown on the number line and also shown in list form. So outliers are anything that is an extreme value or kind of does not fit in with the rest of the data. Now, there is a mathematical way to calculate for the outlier. You do not need to know that at this moment. You just need to understand what an outlier is and how to identify an outlier given a data set. So again, we're going to look at this data set, and you're going to notice that most of the numbers are going to cluster in a certain way, but then you're going to have, in this situation, two numbers that do not quite fit in or are oddballs compared to the rest of the data. So our data set is 2, 19, 25, 32, 36, 38, 31, 42, 57, 45, and 84. Now they went ahead and graphed all of these on the number line. And you can see that once most of those numbers are graphed on the number line, they're in a pretty tight cluster. However, when 2 and 84 are graphed, they're really far apart from the centralized of the majority of the data. So that would indicate to us that 2 and 84 are outliers in this situation. They are part of the group, but they are very far away. They're not centralized in the middle with the majority of the data, so those would be considered outliers. Here are some examples of outliers in graph form. So we already looked at it just in a data set form, but in a graph form, here's what some outliers would look like. Again, numbers that don't quite fit in with the rest of the data. Oops, let me go back. So we can see here in this graph, this would obviously be the outlier. It is way far off from where the rest of the data goes. It is not following the slope of the data. So this would be considered an outlier. In our second example, this would be considered an outlier here. We've got a cluster of data in the center, and then there's a pretty big significant gap, and then there's an additional data point. So that would be considered an outlier. And then again, in this final graph, this little cluster plot, the outliers are the items that, again, do not follow that centralized measure of center, numbers that really stand out as being different from the rest of the data. So again, circling back to that skew data, what do outliers do to our data? Our outliers is what causes that skew. So if we see any type of data that does not have balance, or is really shifted to one side or another, that is caused by outliers or by uneven data. So we could describe it as left skewed, right skewed, or no skew. That's really just showing where the bulk of the data, if it's going mostly towards the left, if it's going mostly towards the right, or if there's no skew at all. So we can see examples of skew in many different types of graphical representations. We already saw it in histograms. This is an example of it in a box plot. But as you can see, whenever there's a lack of balance, that indicates skew. So now that we've discussed skew and outliers, now we can use that information to determine the best measure of center. So again, best measure of center, the ones that we care about are mean, median, and range. So again, this graphic does have mode on it. We do not need to worry about mode in where we are in 7th grade right now. We're only focused on mean and median. So when you're given a data set, or when you're given a visual graphical representation, they may ask you, or they will ask you, to determine which measure of center is the most appropriate measure of center. So when we're looking for what the best measure of center is, we're really going to look for whether or not outliers are present. So if an outlier is present, or skew is present in the graph, so again, a lack of balance, we're going to want to use the median. So again, the median is that middle data number in a set. Using the median means that the outlier does not impact the data as much as it would if the mean is used. Now, if we have a data set visually that's very evenly spread, we can see that there's no true outlier. Things are pretty much clustered within a centralized range of data, then we can use the mean. So again, if we see an outlier, if we have extreme skew, we want to use the median as the best measure of center. If our data is evenly spread, then we can average it out and use the mean. We're not going to use the mode as well, like we talked about, but we would only use the mode if we only had a few types of values in the data set. Like if our data set was only made up of 1s and 2s, then we could use the mode to establish the best measure of center? Again, that's not something that you're going to be asked to do in this situation. Following best measure of center is best measure of variability. So best measure of variability also describes the spread of the data. Just like with best measure of center, when we're talking about measure of variability, we consider whether or not there are outliers. The two measures of variability that we looked at in class were range and interquartile range. So we already talked about range. Range is when you take the maximum minus the minimum. It's best to use range when there are no outliers present. So we've already established that if we've got no outliers, we want to use range and the mean. When we do have outliers present, we're going to want to use the interquartile range and the median. Now, the interquartile range is a process of breaking down your data into 5 different sections. We did discuss this in class, so you can refer back to the recording from live class if you need more information on interquartile range. For your quiz, however, you really just need to know when to use which type of measure of variability. The range, again, best used when no outliers are present and your data is evenly spread. Your interquartile range is best used when outliers are present. So this is the information that you need for your 7.03 quiz on measures of center. I hope that you use all of the resources that are given to you and you can reach out to any of your teachers if you need any help.